We were just trying to live stream this video, but signal cut out for some reason, so we're going to upload this later if I have room on my phone. Anyway, we wanted to show that the first thing that you do when you're converting a gas grill is to remove, of course, the regulator, because you don't need it. And find one that lets you unscrew the regulator. Some of them is hard wired, so to speak, or hard welded on, and then you'd have to snip it, and that's inconvenient. So it's good if you can get one that you can unscrew. Fortunately, this model, which is the Dynaglow 2-burner with side burner, this one is the cheapest at Home Depot, $139 down to $119 usually for a sale. And it's got the side burner. That's the first thing that we're working on. And what we just showed is that we removed the restriction nozzle or jet from here. In our case, we were able to, this one was able to be screwed out, but we decided to drill it anyway for those of you who may have ones that are glued in. And we just really wanted to show that you drill it out so you have the widest hole possible. And that then, to check that it's working, if you can blow in it when you turn it on, if you can get a nice clear passage, then the biogas will work. So that's why you need this. This restriction nozzle is to make a jet of propane or natural gas, depending on the orifice size, spray out. And then when it sprays out, then it's supposed to pick up air through these venturis, these holes. Now for biogas, you do not want any air coming through with the gas. You want the air to combust with the gas right at the burner itself. And so you want to close these holes up. Aluminum foil works. Aluminum tape is better because it won't come off, but we usually just wrap it in aluminum foil just to close these off so that no air gets in. And you use aluminum foil or aluminum tape in case there was ever an ignition back here. So if you had regular duct tape or something, it might burn that, and that would create a bit of a mess. So cover that up. And that's really all there is to it for this thing, because then when this thing gets put back in, or rather in the inside, sorry, this has to come off. There we go. And this goes back in this way, and that gets screwed on. Then this just sits on it, and you can see in here, that just sits on it like that, with the widest possible jet, and then you cover these up. And then your biogas grill will work on biogas. Okay? The other thing we have to do if we want to use the grill, which we do for other stuff, is you need to take these out carefully, because they have an automatic starter. Sometimes the automatic starter doesn't work well with biogas. Sometimes it does, depends on how wet the gas is, how much carbon dioxide. Once again, these holes here, the venturis, will have to be covered with aluminum tape. That and that on the two sides. You don't cover these holes up, of course, because that's where the gas comes out and ignites, and the igniter. Sometimes we have to tilt this up to close the gap a little bit so that it ignites better. So press that up like that. So you have a smaller spark gap. That helps. You can see on this one here, the gap is pretty big, right down there. So remove that cotter pin. Drop it there for a second. And once again, you'll want to press this in so that you close the gap a little bit. Keep a gap, but a very small gap. And that'll help you ignite. But now getting inside to remove the jets, maybe the best way to do this is to turn this upside down or on its side. Let's see. Yeah, that'll make it better. So you hopefully you have a grill where you don't have to drill, because it's a little awkward getting this drill in here. That's a little hard, and so you'd have to figure out a way to do that. Maybe you'd have to unscrew everything if you had to use a drill. I don't know any other way. I guess you could come in like this if somebody else is looking. Yeah, you could do that. You could do that, definitely. So you could come in here if you needed to, and you could drill it out. All right, so that's not so hard. But if it's removable by wrench, you're in much better shape. You want to give a hand to that? See if you can remove that nozzle. That should unscrew that way. That brass nozzle. Is it coming?
Yeah.
Okay. So in this case, you don't have to drill. Maybe. Some people should be able to unscrew it. Now, should you want to return your grill to running on propane, then you'd just screw that little jet in, and then uncover the venturis that you covered with aluminum tape, and you've got a propane gas grill again. When you drill it out, it's permanent, so you can't do that. And since we have drilled out the other side burner there, you're not going to be using this one with propane. We're making this one a permanent conversion. But some people like to have the flexibility and say, okay, you just screw that jet back in and you can hook it up and use the regulator. You put the regulator back on, hook it up to the propane bottle, put those in. But there it is. That's the offending piece. That's what has to be removed. And once again, I just want to show that for some of you, you're going to get your grills and this will not come out. So you'd have to go in like this with the drill. It takes about, but you're probably wondering, why would I destroy perfectly good venturis? It's just to show you. I would normally just unscrew them like this, keep them, and if you ever want to use it with propane, put them back in. In our case, we'll drill it out, but then we'll buy other ones if you ever wanted to, but I don't see any reason to go back to propane, because look what we got. We got these biodigesters there, and we're going to be using them. So I'll keep drilling this out. And then when it goes all the way in, you can hear it. Whoops. I left that in there. Okay. Never mind. Let me just put that back on.
Some vice grips.
I think I should be able to back this out. There we go. And there you can see we have drilled through the actual jet. And I don't know what happened to the other jet. May have fallen just now. And we're losing our cotter pins. They're over there. Gotta find the other cotter pin. At any rate, yeah. Oh, and there's the other one. Or is it? No. We probably lost it.
Oh, there it is.
You see it?
Yep.
Okay. So just once again, most of you will have grills where you can just unscrew and then you can use it again. Some of you will have grills where they are glued and you'll have to drill through to get them out. That's the difference between being able to reconvert back to propane, just put those back in, or not. And then we'll just take this. Remember that you're going to have to cover these up with aluminum foil, okay, to make this work. And in this case, put this back on like that, get your cotter pin. And of course, you'll have to pull it back out when you want to cover those up. It will not work without covering those up. So for right now, I'm just going to temporarily put this back in. think it went like this. Just like that. Alright. So we'll keep that like that. For now, that's fine because we're going to be taking them off later. Voila! We now have a biogas ready grill except for covering up the Venturas. And let's push this in there. Okay. And as I mentioned, there will be times when the gas is really too wet to use the spark mechanism, that little piezoelectric thing over there. This we can't bend closer, it just won't bend closer. But it may work, it may not. Usually we use a long lighter to get this going. So the only thing we need to do now is screw this in from underneath and screw that in, and we're done. Okay, and just so that we can show you why we're going through all this, let's take you over to what's going to be powering this. So what we have here is we have an IBC tank, Solar City's IBC gas holder, floating gas tank. This is a 1,000 liter tank with a 1,000 liter tank rotated 90 degrees and placed inside with the bottom third lopped off. So imagine this tank here twisted on its side, and then we cut off this section here so it's open at the bottom like a bucket, and it fits down in. And you can see, if you look down under the water line, you can see that what was the top of the IBC over there. There's the top down there. So it's just rotated 90 degrees. We do have a feed pipe in this going 4-inch to 2-inch because there is enough gap space. And then when it goes down, there's an elbow, and then it goes all the way underneath the tank. This would be a standalone digester. If we inoculate this, which we will eventually, with the microbes from our other digesters, or with horse manure or human sewage or alpaca manure or whatever, the lake mud, then this would be a legitimate biodigester. You could feed it, it would produce its own gas, and this would rise up the same way as the Indian floating gas drum digester, the RT India digester, just made out of IBC tanks. That's what we do at Solar Cities. But in places where there's cold winters, these don't work in the wintertime because they're open to atmosphere and the heat escapes and they can get fairly cold, and then they stop working. They'll work fine in the summer. So we have another IBC tank that is sealed and painted black, and here we have a 4-inch pipe going down with a cut at the bottom, goes all the way to the bottom, and that you can feed food waste into. This was inoculated with horse manure. The 2-inch bulkhead fitting with a 2-inch pipe above the water line, reducing to 1/2 inch for the gas to come out. It's a bulkhead fitting right at the top. That's a 4-inch uniseal in a 5-inch hole. Then we have a 2-inch uniseal in a 3-inch hole with a 2-inch pipe with a T, so atmospheric pressure will prevent siphoning, and that's the overspill of the slurry. And then that slurry then goes into another tank that is identically set up, but this one will have air stones going in it to aerate the stuff. We're also going to put a T in here with a valve so we can tap off pure biodigestate or supernatant that's ammonia rich, but it has a slight odor. Some people want to treat the tank, so we'll have both options of using direct supernatant or biodigestate from the digester, or go in and cure it with oxygen, with aeration. And then we have slow sand filters that are being built here, and those slow sand filters will further process the water using a Schmutz-Deck layer of microbes and algae and protozoa at the top of the sand. There'll be settling tanks here. It'll go through and then rise up a pipe here, go into the final overspill as well-treated water that'll be particulate free and odor free. So that's our wastewater treatment area here. We have over here the top of the IBC, the part of the IBC tank that we cut off when we made the floating part. This is the part that got cut off here. And it's nice to use this as a little aquaponics area. You can grow duckweed, you can grow azolla, you can grow water plants, you can put floating raft and do deep water aquaponics or hydroponics in it. So it's nice, we don't throw anything away. So we've got that piece here, and then the overspill could go that way, and you can spill in, and there should be still some nutrients coming out of here, but they've been aerated to go in there. Or we can put our tea there and come over here if we want to sample anaerobic digestate. So we have that. Then we have the 4 cubic meter or the 1,000 gallon water tank, which is our primary digester. It's got in it a bunch of tubes like those over there, 4-inch tubes for surface area. It's got PEX coils running through 400 feet of PEX. And it's the same setup as all our Solar Cities biodigesters. It has a feed pipe going down to the bottom. That's that 6-inch pipe over there. It has a 4-inch pipe coming up with a vapor lock braking or siphon braking T on it, and then going down and spilling the effluent into the tank. The theory is, from the German experience, we should be able to get 80% of our gas from our digestion from this tank, and an additional 20% from this. And then that gives you the most gas out. And then we can also feed this one. This tank here has the gas out, once again, with a 2-inch bulkhead fitting, rising up over a foot over the top of the water line. The water line is, we raise the water line all the way up about a foot, and then it reduces to 1/2 inch, so there'll be no clogging for the gas to come out this clear PVC tube, combining with the gas out from this, and then into the gas holder over there. This can take approximately 30 gallons of food waste a day. So think of one of those 27 or 30 gallon totes that you get. That's the best way to collect food waste. And this one can take a 5-gallon bucket's worth. So we can get about 35 gallons of food waste a day ground up with water into these digesters and hopefully produce up to 5 or 6 cubic meters of gas a day, which will run that grill on the side burner as long as 12 hours a day, maybe around from 8 to 12 hours. Certainly we should be able to get the 2 or 3 hours necessary for cooking. We have 2 1-horsepower incinerators, the Evolution XL models that are triple grind, and we have an air switch here that we turn on via this. It's not plugged in right now, and if I do want to plug it in, let me turn this on and go to this. Right now this one's on. So we have 2 of them, and we can switch between them, but this button one is always on. So the double switch that they have here switches one or the other on, and then if we want to turn them off completely, then we switch them off here with this reset. That is going into a macerating toilet pump right here that also has a blade in it for grinding up toilet paper. And then we can switch between these because you only can use these 10 to 15 minutes before they overheat. Then they would trip the overload, circuit overload, heat overload button here, and then you have to wait for them to cool down and pop that back in. Goes through here. When this fills, it pumps up. That's got a float valve in it, and puts the food waste that's ground up down the pipe. We also have a sump pump in here, and this sump pump is a sewer sump pump that sits on these big legs and can handle 2-inch particulate matter, and that's got a float valve. And these out of here. That is going through a 2-inch pipe and going into the top of the feed pipe. So we have the option of grinding food there, or we can take some more if we want to use more manure, or if we want to take unground food waste and do as the Indians do and just let it sit in here and rot. Then it can still, up to 2-inch pieces can go in and be pumped up this 2-inch pipe. We do have a 2-inch check valve here, a flap check valve at 2-inch, so we can get 2-inch particles up in here and down in, or we can grind up into 1/8 of an inch using the food grinder. You can also remove that black rubber cap and dump food waste in. It just takes a long time to digest. So if you don't grind food waste at all, and that is something you can do with this 4-inch pipe here too, just take your odd apple core and your banana peel and just dump them in and use a plunger and plunge it down. That's fine, but it could take up to 30-40 days to digest. Whereas when you grind, it'll digest within 24 hours. So there's an energy investment in grinding, but you recoup that energy investment because you get immediate results. So if you want to barbecue on a weekend, you come here on a Friday and you feed it ground up food waste, and then the tank fills by Saturday afternoon, and by Saturday night you're cooking. If you just throw your food waste in without grinding, then you got to wait and schedule your party for whenever it digests, and it's hard to know when that would be. So that's the basics of our system here. We have a lot of flexibility. Unground food can be thrown in there. You could climb a ladder if you really wanted to, take that off and feed that 6-inch pipe, or throw unground food waste that's no larger than 2 inches into here and let it slowly get soft in time in the hot sun and fall down and get pumped up with this, or grind it up here, go through the macerator and in. A lot of options that we have. So we're trying to show every possibility for a core biogas system that can be built by anyone, anywhere, out of local materials. And then around this, because this is the solar plexus of the Nexus, we're going to have over here a vacuum tube solar hot water system, probably a 20 vacuum tube like they have on the other side of the property. And it will be with a circ pump pumping hot water through here, through 400 feet of PEX, returning to the solar hot water collector here, and then continuously keeping this hot whenever the temperature sensors tell us that it needs heating and there's sufficient heat. We also will have a tank on the solar hot water system that'll hold about 80 gallons, and then we can do hot water grinding and hot water feeding through here. And interestingly, this is hot right now. This water's hot simply because the hose, this black hose, is going all the way down there, and that's a solar radiator. So it's really funny that however many gallons this 500 or 600 feet of hose is having is hot water in the day. But the solar hot water collector works better. Then we're going to have photovoltaics over here, a 1 kilowatt system, which will be able to power with an inverter, probably a 3,000 watt inverter. Will power the incinerators, power the macerating toilet pump, power the sump pump, and power our electric guitars and bass and keyboards when we do solar powered rock concert festivals, and streets of lights around here. And who knows, fans, air conditioners, the sky is the limit. So this is the core of what will be a sustainability hub. There will be hydroponics and aquaponics and tower gardens, and there will be raised beds, and there'll be a food forest here. That's our vision, to make this a sort of all-in-one, all-inclusive food, energy, water nexus with zero waste. And then eventually we can look at what to do with plastics here as well. So you're looking at the start of something beautiful. And of course we're going to have barbecues on the grill. So thanks a lot if you've been watching, and please do try this at home.